All right, let's take a look at number 7 and 8 on the surface area exploration. Number 7, the surface area of R2-D2's head can be modeled by a hemisphere with a diameter of 18¼ inches. I know because I measured it. Ignoring the various scopes and gadgets that surround its circumference, find the surface area of R2-D2's head. So once again, we're just using this geometric figure to model something in real life that's maybe not an exact fit, just like that traffic cone was an exact fit for a cone, but we used it to get a pretty good approximation. We're doing the same thing with R2-D2's head. So maybe I sketch myself a picture here of R2-D2's head. Here's the dome shape, and then come around for this like great circular base right there. And then maybe it gets some shading. Voila. All right, what number did they give us? They gave us 18¼ and it was the diameter. So be careful with that. That is all the way across here. That's the diameter, 18.25 inches. All right, if I'm going to use, let's say, the surface area formula, I don't need diameter, I need radius. So we need to cut that thing in half. When we cut that in half, let's see, half of 18 is 9. Let me, whoops, go over here. Maybe, what is going on? Right, zoom in a little bit more. Half of 18 is 9. Half of 25 is 12.5. So that's 125. There we go. So there's our radius. Now we have a decision to make. Remember when we're writing down our formulae for surface area for a hemisphere, there's actually 2 of them. We have 3 pi r squared. Is it 3 circles? Or 2 pi r squared? Is it just 2 circles? In other words, we need to make the decision to include the great circular base or not. Well, think of it like this. If you're going to put a new coat of paint on R2-D2's head, would you have to paint the part that makes the circular base here? Would it be exposed? And I don't think it would, right? It's actually a hollowed out piece right there. There's probably some circuitry in there or something. Actually, it's a guy. It's a little guy that fits in there, but whatever. Which means that we're not going to use 3 pi r squared. We're going to use the 2 pi r squared because we're not going to include that great circular base. Since we have our radius, we are good to go. So let's go ahead and multiply 2 pi times my radius of 9.125. Come on, 9.125, which we will square. It's time to break out the calculator. Let's see, what do we have here? All right, we already have some numbers in here. Let's clear them out. And it was, I do believe, 9.125, which we are squaring. There you go. It's this number. I don't necessarily want to have to memorize that to write it down, so I'm going to split screen this again here. Oh, where are we? All right, so we just squared our number. That's the number that's right in here, but we also need to multiply it times 2 pi. I'm going to get an exact answer first by just multiplying it by 2, and then I'll tag the pi at the end of it. So over here on the calculator, let's hit times 2. So answer times 2 to get 166.53125. That's easy enough to remember. So your surface area is equal to exactly 166.53125. And then put your pi at the end of it. Here's the exact answer. What are the units on this? Inches, so inches squared. And it doesn't indicate whether you're going to find an exact or approximate. So I would always start with that exact one, and then we could always approximate it if we feel like it at the end. We have a choice. We have the freedom of choice. So let's go ahead and get both of them. And all I have to do is just hit times pi here and get approximately equal to, our surface area, approximately equal to 523. Let's say 3 decimal places, 173. The 3 after that tells that 3 to be still, inches squared. And then, you know what? We should go ahead and box our answers there. All right. One last question here, number 8. At the equator, the Earth has a circumference of 24,900 miles. Find the surface area of the Earth, ignoring the relatively tiny bumps and fissures that mar its otherwise smooth surface. Earth has a smooth surface? Well, kinda. I mean, if you zoom out far enough, would you notice the height of a mountain? You probably wouldn't. Not only that, the height of a mountain is pretty small compared to the whole entire circumference. So yeah, it is relatively smooth, and we're going to model it with just a sphere. Does it get a picture too? Of course it does. Ooh, there's the equator. And you know what? I don't know what the radius is. I just realized we have the circumference instead, which is 2 pi times r. So that is what 24,900 miles is supposed to be equal to. In order to find the surface area, I need the radius, though. So I'm going to have to divide that thing by 2 pi. Divide by 2 pi. And I would have my radius. Let's keep it exact, because we're going to have to use it again in another calculation. And notice, of course, that we've got we have a number up top that is even, so it should be easily divisible by 2. Let's go ahead and divide it by 2. 24 divided by 2 is 12, and 900 divided by 2 is 450 over pi. Okay, all right, now we are ready. We are ready to find the surface area. The surface area of a sphere, 4 circles, 4 pi r squared, right? And then in the place of our r, we're going to write this number, 12,450 over pi, and then we're going to square that. When you have a fraction that you're squaring, you got to square the top and you have to square the bottom. Now, 12,450 squares, not one that I know off the top of my head. So we'll have to use the calculator again. So I have a clear screen. Let's go ahead and type it in. 12,450. We want to square that number. Okay, we're in the millions. Now, not only that, I'm going to go ahead and do this in the calculator in one go. I need to multiply that number also times the 4 that's out here. So hit times 4. And I get, let's see, this is in the millions, 620,010,000. There's going to be a pi on the outside of that, and this pi that's on the bottom is going to be squared. So we'll have a pi squared on the bottom is equal to 620,010,000. Throw the pi on the top, but also the pi squared from the thing that was in the bottom of the parentheses being squared. Hey, you know what pi divided by pi is? It's the number 1. I'm going to divide a pi into pi squared and get just 1 pi left over. So there's our exact answer, believe it or not. It's exactly equal to 620,010,000 over pi in, square miles? But maybe we want an approximation for this thing. So if I want an approximation, all I have to do is go back to the calculator and hit divided by pi. Where's my pi key again? There we go. Hit enter, and we're still in the millions. Approximately equal to 197,355,312.5. Now that looks like it's an exact answer already, right? 0.5, and then the decimals end. But it's not. And the reason why I don't see more decimal places is because the number is so large, it's using all of the digits that this calculator can possibly display anyway. So there's more decimal numbers here. I don't have access to them at all. So it is still an approximation, and it is still an irrational number. Okay, and then what are the units that go on this? Our circumference was measured in miles, so this must be in miles squared. No, that's meters squared, sorry. Miles squared. All right, box your answer and call it a day.